the event A and event B might occur at the same time. So we need to understand that relative probability. Okay. So that relative probability means when event A is occurred, let's say event A is occurred, you need to know what is the probability of event B occurrence, or vice versa. When event B has occurred and you wanted to know the probability of event A occurrence. Okay. So in this scenario, you can see that we have two events, event A and event B. And when it comes to the conditional probability, when A and B are written, so this is the probability of A when event B has occurred. You know the probability of A intersection B? A intersection B means the event A and event B has occurred at the same time. Okay. And the probability of event B, the occurrence of probability of event B. And at the same time, the vice versa, which is probability of event B occurrence when event A has occurred, is equals to the same, which is A intersection B, and by the probability of event A. Just in case if you guys are carrying, please put them on silent. So here you can see that the probability of B when the occurrence of event A is occurred, you can see that the occurrence of A intersection B when the two events has occurred at the same point, and you know the probability of one specific event given. So in this scenario, you can see that you have A of P by A equals to A of P of A intersection B and by P of A. So now we understand how the Bayes theorem has occurred. Thanks. I'm fine. Oh, one second. We'll take it. Yeah, make it. HDMI connect చేశారు సార్. HDMI connect చేశారు సార్. Yes. So because so everyone can hear me now, loud and clear. No bass issues, no crackling sounds. Everything clear. Okay. Hello, hello. I want everyone to look at the screen and you guys can understand what I'm going to explain, right? Okay. So everyone is clear till now, which is the step one, understanding the conditional probability. Clear? Or you want me to repeat it? No? Clear? Okay. So the next step is how are we going to relate these two probabilities? Okay. So this is the joint probability. So as here you can see that we have the probability of A intersection B when the event A has occurred and at the same time event B has also occurred. And the probability of both events, which is A intersection B. So here also you can see that we have a intersection B and here also you have a intersection B. So now what are we going to do? Going to do a small mathematical calculation. So now we will be transposing this A intersection B equals to A no, probability of A when occurrence of B into probability of B, which is we are just transposing this probability of B to the other half. Okay, on the left hand side. So now what happens? So you can see that we have A intersection B equals to probability of A when probability of B has occurred and multiplied by probability of B. At the same time, from the below equation, you can see that we have probability of B by A, which is multiplied with probability of A. Now we can see these two values are equaling to the same value, right? Which means these two values can be equated, which is as below. So probability of A when B has occurred into probability of B equals to probability of B when A has occurred into probability of A. Right? Is this clear till now? So now we'll try to understand when you are going to identify the probability of A when probability of B is occurred, event B has occurred, event A also occurred, you wanted to know the relative probability. When these, let's say, when event B is occurred and you wanted to know what is the probability of event A occurrence when B has already occurred. Okay, that's when we'll be using the base station. So now you can see that probability of A when probability of B has already occurred equals to probability of B when A is already occurred into probability of A by probability of B. So you understood how we have derived this equation. So oh,
స్క్రీన్ షాట్ అయిపోయిందా? స్క్రీన్ షాట్ మళ్ళీ స్క్రీన్ షాట్ చేయాలి. అవుతుందా?
Yeah. So can anyone explain what do you understand out of Bayes theorem? Yeah. It's okay. Even if it is wrong, I'll correct you. Not a problem. Audible? Ask a question. Not clear? Yeah. Go on. Sorry. No, actually, you're telling right. So continue. It's okay. So I'll just reiterate what is meant by a Bayes theorem. So when event A has occurred, you have a probability of event A, probability of event B, and you also know the probability of two events occurring at the same point. So you have three probabilities, and you wanted to calculate at any given point. Okay, you wanted to calculate probability of event A when event B has already occurred. So in this scenario, we'll be using Bayes theorem. Okay, is this clear till now? So the next question. So the next question goes to the extraction of data from the database using Python. Okay. So first, let me explain you why.
Screen share. That's good. Yeah. Whenever you use database, what is the use of you interact with database? And you search name, shoe, some shoes, and you want to someday you
You can see that you something that happened on that and you see that. Data that you are using. That you are using. Based on that, it is identifying and it is suggesting you that one. Like there is something going to training. Okay? You will go to training, so let's make the video picture track. And so there is nothing behind which we are not the
And that is being trained with humans, right? So this is how we are going to use the machine learning. The machine learning works with hello. Yeah. So the machine learning works with data. Okay. There are multiple kinds of databases that are available, which are SQL based, which is we have a structured tables, and we also have no SQL databases, which where we'll not have any structured data, right? So these machine learning algorithms has to consume the data from the database. When you're using Instagram, you're scrolling something and you're liking some posts, that data will go and sit into the database, not into the algorithm. So what the algorithm does, it will consume the data that we have in the database. It will retrieve the data, put it into the Python code or any code that was written in C++, and that data is being fed to the algorithm. So this is the reason behind you have to know how are we retrieving the data from database. Is this clear? Is this point clear? So you understood why this specific experiment has been given to you? Clear? Now let's see how we are actually creating a database, putting data into the database. The experiment itself will actually is majorly about reading the data from the database. I like to demonstrate the CRUD operations, basic CRUD operations from Python itself, so that you'll understand on an application standpoint as well. Okay. Is the screen visible? Everyone? Okay. So for this experiment, I have created a class called as database manager. So the major use of this database manager is to initialize a class where it will be interacting with the database that you are going to create. For this experiment, I have used SQLite, which is online database we have free. And there is a reason behind why I'm using the SQLite as a instance. Okay. Yeah. So there is a reason behind why I'm using some online databases. Every computer we can have a database, and we can install any sort of databases. But in general, the data that you are going to consume will not settle in your local database or your local PC. Usually, this data resides on some server which is already there in the cloud. So if you wanted to browse that data, you have to read the data from the existing database which is already hosted online. Okay. For that example, I have taken SQLite, which is an online database provider. Okay. Is this clear? Clear? Yes? No? Okay. So here you can see that we have a database manager, and this is used to initialize the class with the database name. So once you provide the database name, it will create a database with that name. And on that database, you can create multiple tables and you can read from that. Okay. Hello. Yeah. So this is the constructor that I have created. So here you can see that we have a database name, we have a connection and a cursor. This cursor is used to, hello. Okay, settle down fast. Hello. Settle down. Okay. So you can see that for the new ones, I'm actually explaining an experiment where we are dealing with the reading of databases. Excuse me, don't make noise. So yeah, so I was kind of explaining why we are using some data which is there in the database, and the experiment deals with, we have a database which is hosted online and we are actually retrieving the data from the database, and we'll be using that data for machine learning algorithms. We have a question which is we have to read from a database, and I was going to explain also the CRUD operations where you will be using that same kind of thing in your application development as well. Okay. Is this clear? Yeah. Okay. So here you can see that I have a constructor, and in this constructor, I am actually assigning a database and establishing a connection, and this cursor initializing a cursor. The reason why we are initializing a cursor is let's say you have a query and that query has to be executed from the Python standpoint, right? So we'll be using this cursor to do that. So in order to establish a connection, you have to use something called as SQLite 3.connect. So this will actually establish a connection from your Python code to your database which is hosted online. Okay. And you have a cursor, and I have initialized with the connections cursor. And if you wanted to disconnect, let's say you have some operation that you wanted to do over the database, and that is done, you have to disconnect that server, right? Or else in real world application, what happens? The server will be continuously running, the data will be fetched multiple times, and there will be a huge cost. So that was the reason we'll be disconnecting that specific data or the connection that you have established. Okay. And there is a function that I have written for the create table. So you have a database which is already created and you wanted to create a table. So this is a simple query that I am going to do. which is if a table does not exist, you need to create a table with auto increment key as a primary key. Okay. And for every action that every query that we have, we need to execute that, commit it. So there are two stages. Okay. The first stage, you have to have a query that needs to be running. The second is the cursor has to execute that. That execution is done and that data has to be committed. SQL runs on a transactional basis, right? So SQL runs on a transactional basis. So when there is a transaction that is getting occurred, okay, so that transaction has to go into the database. You're actually doing some read operation, write operation, or anything. There is a transaction that happens in a SQL server. So in that scenario, what happens? That data has to be committed. Let's say you have deleted something, or you have written something into the database, or you have updated something into the database. So in all these three scenarios, what happens? The data has been modified. And once the data is actually modified, that data has to go into the database using a transaction. Okay. So in order to get that done, we'll be committing that data. So likewise, I have a few more methods which is related to the insert, and the other one is read data. So I'll just explain you how we are reading the data. So here you can see that we have multiple clauses. If we don't need a clause, we need not use one. If not, we'll be getting a data on entire data of a table. Let's say we have a table and we have multiple records inserted in it, and you wanted to get the data out of that table, right? So in that scenario, you just need to write one simple query which is select star from the table name. If you have any specific conditions, then we'll be using the where clause, right? So this is how we have a SQL query. And if we wanted to have any where conditions, we'll be applying that in the where clause. Okay. Is this clear till now? If not, if there is no where clause, let's say there is no where clause, in that scenario, then we'll be directly executing select star from the table name. And once you get the data, you'll be returning that. So all the data that you get will be going into the results, and that results are being returned to the method call. Okay. Till now, clear? Everything? At the same time, we have update data and delete data. So once I'm done with this class, I'll share you with all the code. So here you can see that I have created a database which is called as mydata.db. So this is a database that I'm going to create, and I am inserting the data table into these records into the table. Okay. So we have 3 records, and I am doing the show table. This show table will display what are the data that is there inside this database. And here you can see that we have the data being displayed like this. Okay. And now what we are doing. So here you can see this is an entire table content. And if I wanted to have a where clause or order by clause, these are the conditions that I am going to do. So I am trying to display the data on an orderly basis of the name. So in this scenario, I have given an order by clause, which is by name, meaning that will be sorted on the basis of name. So here you can see initially it was John, Alice, and Bob, and now it is Alice, Bob, and John, which is sorted on the basis of the alphabetical order. And now you can see I kind of applied a limit. In SQL, we'll be having an option called as applying a limit. If we wanted to have, let's say we have hundreds of records and you wanted to see the top 10. So we'll be using limits, right? And order by age descending, meaning let's say we here we have a age and we wanted to see the data on a descending order of age basis. So you can see the data is like this. So that here we have applied the limit of 2 and we got the data of only 2 records. Okay. And this is a normal select query and you wanted to get some data. And here you can see that data is being displayed. So this is the select query. You can directly use this statement, which is a custom select query. You can write the query in this format and directly execute like this. But this is not a safest way when you're dealing with the multi-threading concept and all. But when it is a single thread, this is how you are going to do it. Is this clear? You understood why we are actually using the data for machine learning and what are the use cases and why are we actually reading that from a database? Is this point clear? Majorly established? So this is the reason behind why you have got this experiment, to let you understand what are the use cases of having a database, reading that data from the database and using that in the machine learning algorithm. Clear? Till now? No questions for the new ones who have joined? So I'm just going to reiterate what we have till now for the ones who has joined just now. So before you entering into the class, I have explained about the Bayes theorem. The reason why we are actually using the Bayes theorem is it is used to predict the probability of one occurrence when another event has already occurred. Okay, so this is how this is the event A and event B has occurred. So in this scenario, you wanted to understand the probability of event A occurrence when event B has occurred. So event B has already occurred and you wanted to understand if that event A occurs or not. Okay. Usually there is a relative factor. So if you wanted to understand that relative factor and understand, identify what is the probability of that event occurrence when already a subsequent event has already occurred, then we'll be using the Bayes theorem. So this is one of the explanation we have, which is when probability of A occurrence when event B has already occurred equals to event A in event B occurrence probability is already given and event B occurrence is also given. Likewise, we have the same value, which is A intersection B by probability of A, and these two values are equal because we have probability of A intersection B, a probability of A intersection B in both the statements, okay, equations. And now you can see that we have these values being equal values, which is pre of A, B when A, B is already occurred and you wanted to know A, and probability of B is already given. So in this scenario, as the left hand sides are equal, we'll be equating the right hand sides, and that's when you'll be getting the Bayes theorem equation. This is the equation. So this equation is used to predict the probability of event A occurrence when event B is occurred, and we also have a vice versa, which is probability of B occurrence when event A is occurred. So in this scenario, what happens? This PA by PB will be transposed to the left hand side, which will be returning into uh, probability of A occurrence when B is already occurred into probability of B by probability of A. So we have a example where is a question on your the list of experiments. The first question is when the probability of A and B, meaning we have a question. I'll just explain you that as well once again. Let's not take much time here. So the question is the probability that it is a Friday and the student is absent is 3%, which is A intersection B is 3%. 3% meaning 0.03. Okay. And since there are 5 days in the school, 5 school days, and at any given point in a week, it is a Friday, the probability is 20%, meaning 1 by 5 equals to 20%. And as per the equation, probability of A intersection B is 0.03 by the probability of B is 0.2 equals to 15%. And that's what we are actually showing here. Okay. Is this clear? Till now, no questions? Okay. Let's move on to the most interesting part. We have an algorithm called as K nearest neighbors. So if you have machine learning classes already done, You might be aware of how the KNN is calculated, you know? Yeah. So I'll just kind of explain you what KNN is, what are we using, what is the use case of a KNN. Okay. KNN is most probably used for identifying the classifications. Let's say there are boys and girls, or true or false scenario, or let's say there are multiple categories. So if you wanted to predict a new, let's say you have sorry, out of 100 members in the class, let's say uh, there are 40% women and 60% men, and there is a new student that is going to come in, and you wanted to find the probability, and you wanted to classify that student whether it is a woman or a man. So this is a practical scenario where you will be using KNN. We will be having some dependent factors and independent factors. So dependent and independent values will help you to predict that. So I'll kind of explain you with a simple example. Hmm. Okay. Yeah. So first, let us understand what the data is first, and then we'll go into the question. Okay. So here we have a data of 5 students. They have attempted 2 exams, which is maths and computer science, and out of which out of 10, let's say they have got 4 and 3, and that person is failed. And you have multiple values like this, and you have a 6th student with marks of 6 and 8. You wanted to classify whether the person has passed the exam or failed the exam. Is the question clear till now? Atangala. Okay, nice. So we have multiple students. Let's say we have 5 students who has given 2 exams, one maths and another one is computer science. Okay, there is a slip test, and out of 10 marks, the student 1, 2, 3, 4, 5. So the student 1 has got 4 marks in maths, 3 marks in computer science, and the result is false. Likewise, we have another student which they have got 6 marks in maths, 7 marks in computer science. The overall result is pass. Sorry. So now we have like this 5 values and we have a 6th value. You need to predict the person is pass or fail. Is the question clear till now? Okay. For this, we'll be using KNN. KNN meaning K nearest neighbors. So this will help you to classify the data on the basis of the K value that was given. Okay. So let us take the K value is 3. So the K value, so the reason why we'll be using this K nearest neighbors is classifying the data. And first you need to understand this K nearest neighbors will not learn your data. So usually most of the machine learning algorithms will actually learn your data and they will first, after learning the data, then they will feed that to algorithm and the algorithm runs and you will be getting some sort of predicted value. So that's how the most of the machine learning algorithms works. But KNN is not like that. It will only memorize the data that you have given. So here the data that I have given is not being trained actually. Your algorithm is not trained. It is only memorizing the data that you have, and based on the data that you have given, it will just calculate if that value is classified either 1 or 0. Okay. Is this clear about KNN? Yeah. So this K is nothing but the number of neighbors that you are going to consider. In this scenario, we have, let's say we have 5 values, right? So the let's say the total number of records or the data points that we have are n. The K value that is determined should always be less than the number of the records that were there or given to us in the data. So now we have 5 records and we are taking K as 3. Okay. Based on this, we'll be trying to calculate if the new student value is pass or fail. So everyone is aware of the Euclidean distance that we have learned in our +2 and schooling. Euclidean distance, right? Let's say we have 2 points. This is x1, y1, x2, y2. So you wanted to understand, calculate the distance between these 2 points, which is A and B, right? So we'll be having x2 minus x1 whole square plus y2 minus y1 whole square under root. So this will give you the distance. So this is the distance formula. So everyone knew this. This is called as Euclidean distance, right? So we'll be calculating this Euclidean distance for each and every value that we have. So here we'll just slightly modify this value as root over. We have an observed value. So this is the value that we are going to predict, right? So we need to understand which is the nearest neighbors to this point. Okay. This is the observed value. This is the actual values with which we already know, right? So we'll be using x naught 1 minus xa1 whole square plus x naught 2 minus xa2 whole square. So this is just for your reference and understanding. So now we'll calculate for this, which is root over. So the m value is 6 here and CS value is 8 here. So here m value is 4, CS value is 3. So 6 minus 4 whole square plus 8 minus 3 whole square. Likewise, 6 minus 6 whole square plus 7 minus 8 whole square, or 8 minus 7 whole square does not make any difference. Minus 8 whole square. Here this value will be 6 minus 2 is minus 2 whole square, which is 4 plus 0, which is under root 4 equals to 2. Here 6 minus 5 is 1 is root over 10. Root over 10 is probably 3.16. Here 6 minus 7, which is 1, 0. Under root 1 is also 1. Here also we'll have under root 1 equals to 1. And here 6 minus 4 is 2 square plus 8 minus 3, which is root over yeah, this is 1 8 minus 5, yeah. $29, it is 5.38. So now you can see that we have multiple values here, right? So these are the distances from the point which is 6 comma 8. Okay. So out of which, what are the least 3 values? Out of these 5 values, what are the least 3 values? 1, 1 and 2, right? So this is 1, 1 and 2. So this is the second value, which is this, and the last one. Okay. In all the 3 scenarios, what is the final outcome? Pass. So when the person gets 6 and 8 as a combination, the person is pass. You understood how we have classified the data? What is the general use case of KNN? Is this clear? Everyone? Okay. So now I'll kind of explain you how we have implemented the KNN algorithm in Python. Till then, till that point, everyone is clear? No doubts? Clear? Okay. Even in KNN also, we'll be having KNN classifier and KNN regressor. Okay, there are two kinds of classification KNN algorithm implementations. So the one that I have just shown you is a KNN classifier, and we also have something called as KNN regressor. So the general use case of regressors is to predict a value. To predict a value, not a result. The classifier will actually classify the data given to you into multiple types. Okay, that's when the KNN classifier comes into the picture. When it comes to the KNN regressor, okay, KNN regressor will help you to understand what are the values that we have and predict the outcome. Outcome meaning that is a quantified value. Okay. So in general use case, let's say there are 6 subjects, and in this example, I have taken 2 subjects as a reference, right? And here we are telling pass or fail. Let's say you have one value in out of these 2 subjects, you're given only one value, and you have to predict what the other subject, the person is getting. How many marks the other person is getting in the other subject. Okay. So in that scenario, we'll be using KNN regressor. I'll explain you that what is meant by KNN regressor. First, we'll see how the KNN classification is done. How is that implemented? Till now, how the classification is explained. So you understood everything till now? KNN classification, clear? Okay. Now we'll move to the implementation. So before that, you need to understand. Hello? Yeah. So before that, you need to understand how we'll be training a model. We have a model, all these algorithms we have will be trained with some data. So generally, you have written an algorithm and you wanted to see how accurate it is. Okay. In that scenario, you have written a code. You have to understand what is the accuracy. So in that scenario, you will be having a data. Okay. That data will be divided into two parts. Okay. Two parts. So the first part will be a training data. The second part will be the data that you need to predict. Usually, let's say you wanted to see how accurate are you, right? Generally, if you wanted to see how accurate are you, what you will be doing? So usually some class tests or everything that you put will usually help you to understand how accurate are you, how knowledgeable are you, because they will have some reference to check, right? In every exam, they'll have some reference. So if that answer is true or not, if you have that already, the data is already there to check and tally whether the data that you have provided and data that the lecturer is also looking at are the same, then only you'll be getting the marks, right? So that's how we'll be doing. That's how we'll be doing in machine learning algorithms also. So first we need to understand the data that we have. We'll split the data. We already have the data. Let's say there are two values. Yeah. Okay. So let's say this is the X value and this is the Y value. Okay. In the last example, what we have done, we are having three different values and we are actually identifying what is the result. Okay. This is generally how the KNN is doing. But when it comes to a machine learning algorithm, you have a X value, you already have a Y value. So this is the input or independent. Input or this is the independent value. And this is the outcome or dependent value. Dependent value. But if you wanted to see if the algorithm that you have written is actually predicting the right values or not, then what you will be doing? You have to, let's say here we have 12 values. Okay. We'll be dividing that data into two parts. Let's say we have divided it till here. We have 8 values and we have 4 values. Okay. So we'll consider this data as training data. You will not give this data. So this is the Y actual. you'll only give this data to predict as an input to your algorithm. Okay. So you will have this data. With this data, you will be training your algorithm. So once your algorithm is completely trained with this data, what we'll be doing? We will be giving this as an input. So hello. So your algorithm has to predict this data. Let's say you don't have these values and the algorithm has to predict this data. So it has predicted some values. So let's say this is out of these 4 values, 3 values are correctly, it has predicted correctly. So the predicted values are, let's say for 19, it has given some 20 value, 101, 120. So these values will be Y predicted. Okay. So you can see that it is almost correct. You have a you need to understand the accuracy point. So now you will be comparing this value with this value and calculate something called as R squared. If this R squared value is in between, this R squared value will be usually in between 0 to 1. And if the R squared value you calculate is near to 1, then it is considered as good algorithm. If it is near to 0, your algorithm is not that accurate. You need to tune your algorithm. So that's how the machine learning algorithms are built and the accuracy has been increased. So is this process clear first? How are we validating the machine learning algorithms that we write? Clear? Questions? No? I have a explanation for that also. I'll show you. So till now, this clear? Okay. So now I'll explain you how this is being written. Okay. So I have explained you how the algorithm works. How do you identify the accuracy of the algorithm that you have written is being calculated, right? Hello. So in this scenario, this is how you are going to calculate the R squared value. This R squared value is nothing but 1 minus the sum of residual sum of squares and the total sum of squares. So the residual sum of squares is the yi minus y cap whole square, which is the difference between the actual and predicted values. And these are total sum of the squares, which is the total variance of the data set. So this is the total variance of the data set, meaning I have given you 12 values, right? So that is the variance of total 12 values. So once you have calculated these two values, then you have to replace these values here. So this is meaning this is the sum of the measures between the actual and predicted values. So yi is the predicted value, which is the cap, and this is the existing value. Okay. Now we'll see how the KNN is implemented. So as I told you, there is something called as KNN regression. I'll explain you about the KNN regression later. For now, we'll discuss about the KNN classifier. Okay. So as I told you, we will be using the Euclidean distance as an the distance calculator between the multiple k values or multiple data points. Okay. And we also have the k value, which is 3. Okay. We have taken k value as 3, and the distance metric is the Euclidean distance. Okay. So now we have x train value, y train value. Will be having usually 4 types of values, which is x train, y train, and sorry. Okay. Yeah. So x train, y train, and x, which is you have to predict. These are the inputs to your algorithm, and the other one is the ones that you need to predict. So that value will not be given. Okay. So this is the fit. So fit meaning you will be assigned 2 different values, which is NDRS. Usually we'll be dealing with the NDRS as an input in KNN algorithm. And here you can see that this NDRA is being trained to the x train values, and the NDRA of y is being given as y train values. And here we'll be calculating the distance. So this is how we'll be calculating the Euclidean distance. So I have told you the sum of x2 minus x1 whole square. At the same time, we will be doing the y2 minus y1 whole square as well. This is the common value for two values. Okay. And we'll be having the get neighbors. So at the end, what we have done in the KNN classifications, we have taken 3 values. So we have identified what are the 3 nearest values, right? 3 nearest values to the given data point. So that's how will be identifying the neighbors to that point. And this is how we are going to predict the end values, meaning the classified value. And this score is nothing but the accuracy. Okay. So I'll kind of explain you what's happening here. So here we have 2 values, which is k, and the distance metric, which is Euclidean. And these values will be assigned to these data members in this class, which is KNN classifier. And this fit will be using to fit the model using the training data. Out of 12 values that I have given, the 8 values are considered as the training data, and the rest 4 are used for the prediction purposes. Okay. This x is the training features of n samples, and y is the target value. Target value meaning these are the outcome values. Okay. And when we are calculating the distance, this is the normal distance formula that I have done. So I hope you are well versed with that logic. And coming to the neighbors, so we'll be identifying the k nearest neighbors. So in this k nearest neighbors, we'll be taking the NDR as an input. Okay. And this should return a tuple. So list of tuples, which is the index and distance. So in the example that I have shown you, we have identified the distances of each and every place, everything, right? So we have 5 values. We have calculated the distance from the given point to each and every point, Euclidean distance. Once that is done, we have identified what are the nearest neighbors based on the least distances. And also after that, we have identified the index positions. So we have seen that is in the 2nd place, 3rd place, and the 5th place, right? So for that, we need to understand the index positions. So that was the reason I am kind of returning the tuple of int and float values. Okay. So int and float values, this int is the index And this float value is the Euclidean distance that you have found for that one specific point from the given point. Okay. And this is the predict. So this, with the samples that you have given, it will do the predictions and identify the neighbors, and finally append those predictions to predictions, and this value is being returned. Score I'll explain you at the end. So I have taken a sample data set, which is iris data set. This is already there in the scikit-learn model that we have. You can see that I am using data sets from the sklearn, which is scikit-learn. Okay. The scikit-learn will have multiple loads and loads of data sets, and you can use them. Those are open source and you can use them for free. Okay. So here you can see I have the iris data, and I have got that data from the scikit-learn package, and now I have load that data into the iris. And we have in iris also we'll be having the data which is the independent variables, and also the a value which needs to be predicted, which is the dependent variable or the outcome or the output. Okay. So now you can see that we have split the data into 4 parts, which is X train, X test, Y train, Y test. Okay. And how are we splitting? We are taking the test size of 2, which is 20% of the data will be going into the X test, meaning the test data and the training data. Okay. And this random state 42 will help you to take randomly 40 multiple values and also take multiple iterations from the data to make it more accurate. So now we are using the KNN classifier. Here we have given the K value as 3 and the distance metric as Euclidean. And now we are trying to fit the data, which is the training data. Once you have the training data ready, we are making the predictions with this predict. And I have explained you how we are actually predicting that data. Okay. So here, this is the predictions data. Okay. And this is the Y test data. So you can see that the predictions data and the Y-test data both are almost similar. So there are no much changes. As I have taken a very small data set, most probably you will be getting the things as accurate if the data that you are taking is more, or you have a huge data set, then you will be understanding and identifying the discrepancies between the predicted value and Y-test value. Okay. At the end, you can see that the classification accuracy is 1, which is 100%. Okay. Is this clear till now? Any questions? Any doubts? No doubts? Clear? Okay. And I have also told you that I'll be, yeah, just take a 5 to 10 minutes break. Sorry? Just don't go out. Just have some peaceful team time. Or you have a break, general break now? No? Okay. Uh, Please don't leave. Just take a 5 to 10 minutes break just to make yourself comfortable. That's it. Guys, hello. Uh, hello. Excuse me. Take a quick 10 minutes break and come back early. We'll resume the class from then. Okay. Hello. 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 Guys, settle down. Hello. Settle down fast. Okay. So till now we have discussed about the KNN classifier. So we also have another thing called as KNN regressor. So there is a small difference between the classifier and a regressor. Okay. So what is the difference between a classifier and a regressor? Regressor is used to predict a quantified value. Okay. Let's say we have some value and we wanted to predict the outcome, which is not a specific category. It has a quantified value. Quantity, let's say it has some quantity of a value. So that's when we'll be using the regression. Okay. Even for regressions also, we have linear regression, KNN regression, and there are multiple types of regressions that we have. There are multiple types of regressions we have. So I'll just explain you how the KNN regression works. And after explaining the KNN regression, then you will understand what is the difference between the KNN classifier and KNN regressor. Okay. In KNN classifier, what we have done, we have let's say we have 1, 2, 3, 4 values, and we have 11, 12, 23, 44, 46. And the outcome is, let's say, which is fail, fail, pass, and pass. So here the outcome is classified into two types, which is pass or fail. Right? Clear? So we have categories in it. These two are called categories. Let's say you have, so let's say here we have 4 values, and I am giving you the fifth value as 5, and you need to predict this value, which is a quantified value of y. And considering this as an outcome or output, you have to calculate this value. In this scenario, what happens? How do you calculate? You cannot calculate based on the outcome or the normal simple KNN format that we have done till now. Right? So in this scenario, I am taking a same simple example and will tell you how the regression works. Because now you understand the difference between classifying and regression. Clear? Different? You understood the difference between these two? Okay? Yeah. So I'll take a small example. So guys, okay. So hello, settle down. Yeah. So here we'll be discussing about how the KNN regression comes into the picture. So let us see a small data set. Here, this is the size of an apartment, which is in SFT, So this is the sizes of an apartment, and this is the cost in dollars, meaning thousands. Okay, this is 200,000, and this is 220,000, and this is 250,000. So likewise, all the values are here. So now you need to predict the cost of this apartment of size 875. Okay. In this scenario also, we'll be applying the Euclidean distance. In earlier scenario, we have two different values to consider in the Euclidean distance. And in this scenario, we will be having only one value to identify the Euclidean distance. So it is the same formula, which is root over x2 minus x1 whole square. No, this is a very small value, right? Only single value. So this is at the end of the day, here we only have only one value. So this square and root cancels, but usually this is not the case. This becomes a Manhattan distance. We have two types of distances. There are multiple types of distances, but most commonly used are two types of distances, which is Manhattan distance and another one is Euclidean distance. And Euclidean distance is more accurate than the Manhattan distance, because you will be understanding, if let's say we have multiple number of values, then the Euclidean distance will be more accurate than the Manhattan distance. Okay. So in this scenario, you have 825. So, sorry. So here we have 875. So 875. So you need to subtract from these values. Okay. 875 minus 750. 800. When you apply under root, it becomes an absolute value. This is 120, 125. This is 75. This is, sorry, this is 225. This is 125. This is, yeah, this is 25. This is also 25. This becomes 75. So out of these out of these five values, 1, 2, 3, 4, 5 values, and again considering k value equals to 3, you need to identify what are the nearest three values. Okay. So on the basis of occurrence, 25, 25, and you have 275s, and this is the first occurrence. So you'll be taking these three values. Okay. And considering these three values, the values are 250, 270, and 220. You need to mean this. So this is approximately 246.67, which is 24670. So this is the value that got predicted for 875 SFT. So now you understood why are we using this KNN regression, right? And you understood the difference between the KNN classifier and KNN regressor? Difference between classifier and a regressor? So if you are having multiple values and you want to categorize the data, that's when you will be using the KNN classifier. But when you have multiple values, and you have to predict the value out of it, not a category, that's when you will be using the KNN regressor. Is this point clear till now? So I'll just explain you how we write the code for that in Python. Is the screen visible? Okay. Earlier I have told you this is how the KNN regression works. You have a K value like we have chosen for the KNN classifier as well, which is a K value which is less than the number of values in the data set. Okay. So here we have taken 5 values, out of which the K value is 3. And this will help you to smaller the variance, and this will help you to do the calculating distance. Okay. Now we are taking the Euclidean distance, which is d of x comma xi. This is the same thing that we have done, identifying the Euclidean distance. And we have another thing called as Manhattan distance. At the end of the day, when you have only 2 values, you'll be both the Euclidean distance and the Manhattan distance will be the same, because I have shown you, right? The score, those squares get cancelled, square and square root, and you will be getting the same value. And you will be identifying the neighbors like I have done earlier, and you will be predicting the output. So this is how the outcome will be, which is the mean. Identifying the mean, average of these 3 values by the K value. So that's how you will be getting the Y. So here you can see that we have taken the 750, 800, 850, 900, and 950, and these are the prices, out of which we have found that we have 3 values which were near, which is 250, 250, 270, and 220. Okay. In this scenario, we are taking the mean of the sum of these 3 by the K value, which is 3. And we got 246.67. And this is the predicted value. You understood how the KNN regression is working? Now let's see how the code is being written out of this. Sorry. Now voice. Yeah. Classifier. Okay. So is the screen visible? Yep. So, so earlier I have explained you about the code on KNN classifier. Now we'll be going through the KNN regressor. Okay. So this KNN regressor will take the K value, which is initially the value of 3 as default value, and you'll be taking the Euclidean distance, and aggregation is the mean. So earlier I have taken the mean of the Y values, which we have predicted. Okay. So the K value is 3 in our scenario. The distance metric is the distance metric, which is Euclidean distance. And the other one is aggregation, which is the mean value. Okay. And earlier I have told you how are we actually training the model that you have written, or the algorithm that you have written. And you actually train that with some of the data that you have and identify its accuracy, right? So here also we'll be doing the same procedure. So we have a X train and Y train. We'll try to fit the data of that data that we have come from the training data into ND format, ND array format, and that will be assigned to the X train and Y train using this fit. And here the we'll be calculating the distances. So this is the same Euclidean distance that you will be following. Okay, it is the same example, same formula that I have shown you. And here we'll be getting the neighbors. After identifying the Euclidean distance, then we'll be identifying the neighbors based on the Euclidean distance. As K value is 3, we'll be taking the 3 values from the existing values and which are more near to the point that we have taken. Okay, so that's when the neighbors will be identified. And at the same time, I already told you that this is how we'll be getting the tuple. We'll be identifying the position and its float value, which is the Manhattan distance or the Euclidean distance. And we'll sort that based on the value, which is the distance. And here we'll be predicting based on the X train values and Y train values and comparing that to the Y prediction values. So now we'll see. Yep. So again, I have taken the data from some np.random values and we are trying to sort them. Okay. These are the features. And once we have the values, there are multiple values. We'll try to flatten them and shape them in this format. And you can see that I am trying to split the data again with the size of 20%. And the remaining 80% is being sent to the training data. And again, the random state is 42. This 42 will help you to take multiple iterations and maintain the accuracy. So it is like multiple combinations of data. Let's say here we have told that we'll be taking 80% of data, but we did not tell that we'll be taking the top 80%. We can take the bottom 80%, or let's say we can take the middle 80% as well. So this random state will help you to take multiple sets like that and apply your algorithm on that type of sets and find the accurate values. Okay. So here I have fit that, and now I am trying to do the KNN predictor. So once we have predicted that data, we'll be printing that based on the R squared values. So we have got the R squared score as 0.8462, which is close to 1. I told you that R squared value will be ranging from 0 to 1, right? Which is 0 to 100%. And my code that I have written is approximately 84.62% accurate. Okay. Based on the K values that you take, this graph varies and the prediction also varies. So let's say here we have taken the K value as 3, right? So somewhere we'll take K value as 5. So you can see that earlier when the k value is 3, so first I'll take the k value as 3. And see, this is how the plot was. So here we have taken 3 values as the input values, as the minimum distance as k. And let's say now we have taken the k value as 5. I'm not changing the labels. Just try to understand how the graph has been changing. See, there is a difference between this one, and you can also see that the R squared value has been changed. It is increased from 84% to 87%. So on basis of increasing the value of k, the R squared value also changes. But there will be a point where this R squared value will increase, and from that the R squared value will drop. So you need to identify till what point of k you need to do multiple iterations, till what point of k this R squared value is increasing, and identify that point where it starts decreasing. That is the actual value that you have to take to identify the accurate values. Okay, let's say you have a data set of 1 GB, right? So in that scenario, you are taking a k value of 3. That will not help you out anywhere. If the data set is more and you are taking the k value as very less value, in that scenario, what happens? The R squared value will be very less. In that scenario, we'll be doing multiple iterations, increasing the k value, and based on the R squared values, we'll be identifying the peak point where the R squared value has been uh, highest. And from that point on, after increasing the k value, the R squared value starts decreasing. So we have to identify that declining point and then consider the k value. That is the place where you'll be having the R squared value more, and your accuracy is more. Okay, clear? Yeah. So till now you understood how the KNN is being used, how the classifiers are being used, and KNN regression is being used. But even in regressions also, we have multiple types of regressions. This is like KNN regression, which is completely based on the number of k values. But there is one simple another regression called as linear regression. We'll be discussing that in 1 second, today's or tomorrow's session based on the sequence I'm going. So now, as you people have understood how the k-means so KNN is working, we have another algorithm called as k-means clustering. This is another algorithm which will help you to do the classification again. But this is more accurate than the KNN classification. The reason behind this is the KNN classification is complete. Sorry. The KNN classification is completely dependent upon, calculated upon your data, which is with the Euclidean distance. But the KNN classification, the KNN clusters will help you to identify the centroids. Based on the centroids, the k value, let's say you have taken a k value as 3, and based on the k value, you'll convert that, you'll take that data into that many number of clusters. So when you have multiple clusters involved, and you're actually assigning a point or a value that you need to predict to that cluster, you will be getting more accurate value. That is how the classification will be more accurate compared to the KNN. KNN has its own drawbacks. To overcome that, we came up with a different algorithm called as k-means clustering. So even the k-means clustering itself shows that we'll be using the means of multiple centroids. Okay. So I'll kind of brief you how the k-means clustering is working, and we'll see how that k-means clustering is working in the upcoming session. So So usually earlier we have told in K-means clustering, KNN also, you have seen that we have multiple values that were already given to us. And in KNN also, we'll be given 1 point. So with that 1 point, we'll be trying to identify or predict what is the class of that specific point, right? So even in K-means clustering also, we'll be given the same point, same question, but we'll be applying a different algorithm. So applying that different algorithm will help you to identify the class more accurately. Okay. First, I'll explain you the math behind this K-means clustering. There are multiple points that you need to consider. So this K-means clustering is also called, it is another method which is called as partitioning method. So in this partitioning method also, as I told you earlier, we'll be having multiple data points, right? So even in that data points as well, we have the K value must be less than the total number of data points. So earlier also we have taken K as 3 because the total number of data points is n. Okay, we have 5 data points and we have taken K as 3 because the total data points is 5 and 3 is less than 5. So that is the base rule that you need to consider when we are dealing with the KNN or K-means clustering. Okay, is this point clear? Yeah. So in this K-means clustering, we'll be dividing the data based on multiple clusters. So let's say you have 100 points. We'll be clustering all points into different clusters. If K equals to 3, then we will be dividing the data into 3 clusters. If K equals to 10, we will be dividing the data into 10 clusters. And there is a base rule here stating that when you are clustering a point, clustering meaning you will be taking one centroid and you have to tag that centroid with the point that you are actually calculating. Okay. You have, let's say you have 4 points. You are dividing that into 2 clusters. Okay. Meaning 2 groups. Okay. You have 2 groups, A and B, and you have taken the first point and second point in 2 clusters. I'll kind of explain you here. So let's say you have 4 points, which is 1, 2, 3, 4. And these values are 5, 6, 7, and 8. Okay. This is one data set. And you have pointed that on the graph. 1, 2, 3, 4. And 2, 4, 6, and 8. So I said 1 is 5. One. Okay. So 1 is 5. This is B, C, and D. So this is point A. And for 2, 2, which is this one, which is point B. Okay. 3 and 6 is here. This is point C. And 4 is 1, which is here, which is D. Okay. So now you need to group these values. Now we have, let's say we have taken K value as 2. So let's consider these 2 values A and B are of 2 different classes. Let's say this is 1 and 0, 0, 1. Okay. In these 2 scenarios, A is 1, which is, let's say this is the outcome. Outcome or class. Okay. So in this scenario, you have 1, 0, 0, 1. And the first base rule is to identify how many number of classes are there. Here we have only 2 classes, which is 1 and 0, right? We have to take 1 from each. So in this scenario, A and B are of 2 different classes, right? So this is one cluster and this is another cluster. Okay. Now on, what you need to do is you need to cluster this point to this and this. You need to cluster this C point with either A or either B, but never with both A and B. This should be unique. Is this point clear? So this is one base rule, that thumb rule you need to consider when you are doing the k-means clustering. Okay. Let me take a simple, but this is too simple. I'll try to take another example. Okay. So here we have taken 12 data points. So in these 12 data points, the first two values are of two different types, which is 1 and 0 as the outcomes. Okay. Or consider this, instead of output, we'll consider this as class 1 and 0. Okay. In this scenario, we'll be applying the k-means clustering here. Okay. So in this k-means clustering, first we need to, as k equals to 2, we'll be taking two different clusters. So this is first cluster, which is K1. This K1 value is 185, comma 72. And we'll have K2, which is 170, comma 56. Okay. We have two clusters. We have taken two clusters from two different classes. Okay. In this scenario, we need to take the next value and cluster it with some point. Okay. So in this step, you need to do the Euclidean distance. So the first step, you need to take two different clusters based on the number of k values. And the second step is taking the Euclidean distance with this point to this k1 and k2. Okay. Let's consider this value, this 168, 60 as k. You have a point called as 168, 60. So now you need to take the Euclidean distance between these two and these two. Okay. Which is for K1. Already calculated. So the Euclidean distance formula is root over. So we need to take the distance between K and K1. Distance equals to root over. Our values are 168 minus 185 plus 60 minus 72 whole square. I did not put the values in, just need to calculate. And also we need to do the distance between K and K2, which is 168 minus 170 plus 60 minus 56 whole square. So this values to 168 minus 50. Nine minus, sorry, plus 144 plus 47. Nine. Four. Point 0.47. So here you can see that we have calculated the distance between the K and K1, K and K2. Hello. We have calculated the distance between K and K1 and K and K2. Okay, so now you can see that the distance between K and K1 is 20.8 and K and K2 is 4.47. Out of these two, which one is the smallest one? 4.47, right? Which is K2. So now you are going to assign this K value into this cluster. Okay. After assigning this K value to this cluster, now what you need to do is you need to calculate the centroid. So initially we have considered this K2 value as a centroid because we have taken only 1 point. So that 1 point will be considered as a centroid. Now you have taken two different values. So after taking two different values which are there in the same cluster, you need to identify a new centroid. Okay. So new centroid formula is 168 plus 170 by 2 and 60 minus 56, 60 plus 56 by 2. So the new centroid would be 169 and this is 58. So this becomes your new centroid. Okay. So you have understood the steps, right? So first you need to take two different values from two different classes and assign each value to each cluster. And from then on, you need to take one value, take the Euclidean distance between these two values, these two clusters, and then identify which one is nearer to that. So once you identify the distance between those two and identify the nearest value, you have to assign this value, which is the K value, to that cluster. After assigning to that cluster, you have to identify the new centroid. Okay. Now what happens? Now you need to take the fourth value. And when you are calculating the fourth value, the centroid of K2 is changed to 169, 58. So when you are taking the distance between K and K2, you need to calculate the distance between this point and this new centroid. Okay? Is this clear? So from now on, what happens is you will be doing the same process for each and every point here. Okay? After doing the same process for each and every point, you will be having and you will be ending with two different kinds of clusters finally. And there is no value to be calculated. So that's when you will be taking a new point to predict. So let's say I have given you another point which is 172, 45. Or we'll take, as this is in 50 series, we'll take 62. Okay. So if this new point has to be calculated, you need to identify, you'll be getting two different new centroids. So the centroid you start with is completely different from the centroid you'll be dealing with the last value you have added. Okay. So you need to identify what is the centroid at this last step you got, and then calculate the Euclidean distance between this new point and the new centroids. Okay. Once you identify the new centroids, the Euclidean distance, and calculated these values and identified to which cluster that does this belong to, you will see there are multiple classes values. So you have to identify what is the class does this point belong to, right? So in this scenario, what you will be doing is, out of this 12 points, let's say there are 6 points in this and 6 points in this. Or let's say we'll take 5 points in this and 7 points in this. And finally, let's say 172, 62 belongs to this K1 cluster. Okay. The K1 cluster will be having multiple points in it, right? So in that scenario, you will be taking the mode of multiple points that were involved in this cluster. Mode meaning, let's say you have 5 values, out of which 3 values have 1 value and 2 values are zeros. So the mode will take the maximum value as the recurring value, which is 1. So in that scenario, this final value, as it is belong to this cluster and the mode is having value as 1, this value will be predicted as 1. Okay, this is how the k-means clustering will be working. Is this clear or is this confusing? If you want me to explain it again, I'll do it. Clear? You want me to explain it again? Yes? No? Yes? Yes? No? Raise the hand. It's okay. Okay. I'll write it step by step. Okay. So these are the steps actually we'll be following. I'll just again reiterate what we'll be doing in the k-means clustering again. Hello. Excuse me. So in this example, we have taken 12 values. So these are 12 values as input. Okay. In this 12 values as input, first we need to identify as k value is 2, we need to identify the class of two different values. Okay. Here we are actually having two different values, which is class 1 and class 0. Do you want me to repeat it or not? If you want, I'll explain. If not, you can take the notes over there. Do you want to take the notes or do you want me to explain it again? Explain? Sure? Then you guys are discussing among yourselves. Okay. So I'll explain it again. We are actually taking 12 values over here, and these 12 values have two different classes. So they belong to two different classes, which is 1 and 0. Okay. Out of which initially for k-means clustering, it is completely dependent upon the centroids. Okay. In this, how are we actually calculating the centroid? Is initially we'll identify 2 points of two different classes. Let's say we have k value as 3, we'll be taking 3 different points because we need 3 centroids for 3 different clusters. And every cluster must have one centroid definitely. So this is the thumb rule. And also the another thumb rule is the k value that we are actually taking here should be less than the number of records that we are taking as an extrain value. Okay. So these are the major thumb rules. And also when you are assigning a value to a specific cluster, that point has to belong to one cluster only. It should not belong to multiple clusters at any given point of calculations. Okay. Is this clear? These points are very important. You need to keep this in mind while you are doing or performing this k-means clustering algorithm. Okay. So as you have taken 12 values, initially I have taken 2 values for the as k value is 2, I have taken 2 clusters. For each and every cluster, we have to take one value as a centroid. So I have taken 2 values from 2 different classes. The first class is 1 and the second class has the outcome of 0. Okay. So the first value is 185 and the 185, 72, and second value is 170, 56. So here the k1 value is 180, 70, 185, 72. The k2 value is 170, 56. And when you are, so these are two different clusters. You have two different clusters. Now you need to take a multiple values and assign it to that specific cluster, right? So that is the next step. So for that, what you will be doing is you have to calculate the distance between the new point, which is considered as k. Okay, in this scenario, let's consider this as some p. Okay. So we have to take the distance between the new point P and K1, new point P and K2. Okay. Once you identify the distance, so the distance formula is the normal distance Euclidean formula that I have told you in the earlier examples of KNN cluster, KNN also, which is root over x2 minus x1 whole square plus y2 minus y1 whole square, right? So in this scenario, 168 minus 185 whole square plus 60 minus 72 whole square will be, which is equivalent to 20.8 approximately. And even in K2P also, we'll be doing the same process, which is giving us the value of 4.472. So out of these two values, which one is the least one? Least distance, which is K2P is giving the least distance. So the new value P has to be assigned to K2. Okay. Once the P value is assigned to K2, which is that this third value is already there in the K2. Now, as there are two different points, the centroid will be varying. Initially, we have taken only one value. So one value will exist as a point as well as its centroid. As we have taken two different values, these two different values will provide another centroid. So this is the formula how we'd be doing the identifying the new centroid. x2 plus x1 by 2, y2 plus y1 by 2. So this will help you to identify a new centroid. So now the K2 is not 170, 56. This K2 has been changed to 169, 58. So this is the new centroid of K2. Okay. Now you have successfully added K1, K2 and the new value P, which is in this cluster. Let's say that now we are taking the fourth one. Now let's say this point value as Q. Okay. Now again we need to calculate K1, K1Q, comma K2Q. And here, while we are calculating the K2Q, K2 has been modified to 169, comma 58. Correct? So this is the new centroid. Now you need to calculate with this new centroid. So after this new centroid is there, and you have calculated this Euclidean distance with K1 and K2, and you identify the least distance and assign to that specific cluster. So you have to repeat this process till all the values that were given to the training value is done. Okay. Now the cluster has been formed. You have multiple values. These values are assigned to each and every cluster that existed till now. Now, if I give another value, which is 172, 62, this is a new value that I have given, and you need to predict the class. In this scenario, you again need to perform the same steps again with these new values with the new centroids. Once you have done with this new centroid, you identify the least distance and you assign it to that cluster. Let's say this final value is assigned to K1. Okay. So once you assign this to K1, you need to identify what is the class. So this is the final part. This is the reason why we are doing the K-means clustering, right? In this final part, what we will be doing is, let's say till now, out of this 12 values, let's say 5 values were there in the first cluster, 7 values were assigned to second cluster. In this scenario, we have 5 values. So let's say out of 5 values, we have 1, 0, 1, 1, 0. So these are the final outcomes. Out of which, what is the majority value, which is 0 or 1? 1, right? So the new value will be assigned with 1. Okay? Is this clear till now? So this is how the K-means clustering works. This is small demonstration with a simple example, but in general use case, when you are dealing with K-means clustering, you will be dealing with huge data sets. Okay? I'll explain you how this is working in the code. I have already written that. We'll discuss that in the next session. Okay? Till now, do you have any questions? Today we have discussed about Bayes theorem and reading the data from the database. What is the use of reading the data from the database? And KNN clustering, K-means clustering, KNN regression, and KNN classification. So we have covered these till now. Do you have any questions? You can ask right now. Or if you want me to explain anything again, I'll do that. Any questions? Either you have understood everything that I have told you, or you understood nothing I have told you. There are only two cases here. Classification. So just let me know if you want me to explain any concept in clear in detail, or you have any questions, or if you want me to repeat any concept till now, I'll do that. If not, I'll share you the code.